Hello, everybody. Welcome to this session about develop cloud native application using Oracle Database 21c. My name is Kwasi Mensah. You can see what I do on my Twitter handle. This presentation has been put together with the contribution of Nimala Sundarappa in my team. Preamble to the discussion. This is a typical cloud native application. It's predominantly with a React.js frontend, making REST calls to an API gateway, relaying those REST calls to a microservice-based mid-tier implementing the REST calls. In here, we might be using Helidon or other micro framework such as Micronaut, Quarkus, Spring Boot, etc. So, and then you will see that the application has been Dockerized, deployed on some container registry, and then deployed over Docker, multiple pods, etc. And this Java code is accessing a persistent store. And in this example, the Oracle Autonomous Database. So that's a typical cloud native application using components from the Cloud Native Computing Foundation landscape. Here is the agenda. We'll talk about how to quick start a Java application with the Autonomous Database, how to initialize a Spring Boot application with Oracle JDBC and UCP, which are the frameworks you need to access the Oracle database from Java, how to provision an autonomous transaction processing database, how to connect to an autonomous transaction processing database, and then how to scale a Java database access. This is very important, using either reactive streams or virtual threads, and then how to speed up your Java application using GraalVM native image. And we'll finish up with a summary of all the programming models that we support for connecting to the Oracle database. So quick start a Java application with the Autonomous Database, where you can use your favorite IDE, either IntelliJ or Eclipse, and all you have to do is go to your IDE, file, new project, and you follow the step. You can source the Java code using our sample code on GitHub, and you can see the link over here, or you can come up with your own application. So that's as simple as that, and you could do the same thing using Eclipse. Now, if you want to build a Spring Boot application, how do you initialize the application with Oracle JDBC and UCP? If you don't have if you don't have IntelliJ Ultimate, you have to go to start.spring.io. That's where you will have the opportunity to configure the Spring initializer with the Oracle JDBC. The key point here is to have Oracle JDBC as a dependency, right? And the way to double check that is to check that in the project form.xml, you have com.oracle database JDBC, or JDBC 11. This is important for the remaining of the presentation, to pick Oracle JDBC 11 and not OJDBC 8. And then pick the right version, 21.3, which is the latest, right? So you need to make sure that this is in the project.pom.xml. The other thing we will recommend is, instead of just pulling the JDBC driver, which is the OJDBC 11, you might want to pull additional jars. And we will see in the rest of the presentation that we need complement jars. We need additional jars, such as the UCP, the connection pool, and some other jar files. So the recommendation here is, instead of pulling OJDBC 11, we recommend to pull OJDBC 11-production. This is a set of pre-established dependencies that gives you everything you will need, all the jar files you will need in production. You have the same thing for the debug, observability, etc., etc. Now, how to turn the universal connection pool, which is the Oracle Java connection pool, Oracle Database Java connection pool, into a native Spring data source. We've made some changes. We've made some development in the UCP code to make that possible. So what you need to do is get your application.properties. That application.properties must be on the project root source main resources. That's the resource folder of your project. In that file, you need to make sure that you specify the database URL, the username and password, and then you need to specify UCP properties. For example, Spring Data Source Driver class name equal Oracle.jdbc.oracle driver, right? You need to specify those things. And depending on whether you want to use our feature called the application continuity, which makes transparent failure, database failure for your application, your Java code, you might want to use the replay data source, right? But if you're not in the, interested in how to sustain planned outage, unplanned outages, you can just use the default data source, and you can see the specification over here. More than that, you also need to specify the pool properties. What is the size, the min size, etc., etc. So this is all you need to do to turn UCP into a native Spring data source, and you can see the whole application, the complete application, at the URL at the bottom of the slide. How to provision an autonomous transaction database? Well, you have multiple choices. The easiest and laziest and smartest is to use the Oracle Database Operator for Kubernetes. We have just announced it. So if you have a Kubernetes cluster in the Oracle Cloud Infrastructure, we are in the process of certifying with third-party clouds, but for now we support it in the Oracle Cloud Infrastructure, the OKE, I think, as well as on the Linux, Kubernetes on premises. So all you need to do is to install the operator by using the kubectl command there, and then edit the template. We provide a template for provisioning or creating an autonomous database, a YAML file which defines the custom resource. So you edit that file with your specifics, and then you save and you apply the file. So this way you get the database provision programmatically. So you can include these commands in an automation, like DevOps, CI/CD pipeline, right? If you want to know more about the database Kubernetes operator, please check the on-demand session, Oracle Database Kubernetes Operator, Why Should You Care? The other approach for provisioning is to use the IntelliJ plugin that we have built, we have released on GitHub, and you can see the link at the top of the slide, right? So with this plugin, you will be able to provision an autonomous database. You will be able to get the client credentials, and you will be able to connect to the database using the client credential. The client credentials are generated for the specific instance of the autonomous database that you have provisioned, right? So you need to use that. And in the demo, you will see how we're using this from IntelliJ to connect to an autonomous database, to provision and connect to the autonomous database. You might be able to do the same thing with Eclipse. The Eclipse plugin has been around for a while. Before we have released that one before. So you should be able to do the same thing with Eclipse. How do you connect to the autonomous database? Well, as I said, and you will see in the demo, you need first to get the client credential. It is a set of files, and you can see the list of files on the slide. So you need to get those files generated specifically for your instance of Autonomous Database, right? And you can get it either using the plugin, as you will see in the demo, or you could use the OCI command line interface, as you can see here, the bullet one, where we provide some parameter, and there is a generate wallet command that will generate the client credentials for your specific Autonomous Database instance. You might also use REST call in HTTP post with the parameters, and that can generate the client credential for you. The last option is to navigate manually using the Cloud Console, navigate to your Autonomous Database, and you have the option to say download the client credential, and you can download the credential from there. Now, you get the client credential. You can connect using either JKS or Oracle Wallet. For JKS, you need to make sure that your OJDBC.properties file, this is a new file that we have. We've been releasing that since 19C. And this OJDBC.properties file must be configured to use JKS. And the way to do that is to edit this file, to set the JKS properties, the trust store password, the key store, and the key store password, and save the file. You need to comment everything else, right? Only JKS specifics in this file, and you save the file. And then you need to make sure you have OJDBC 11, UCP.jar, ONS.jar in your class. So that's all you need in order to be able to connect to Autonomous Database using JKS. And you can see the connect string where we have the TNS admin variable, which points to the location where your client credential zip file has been unzipped. If you choose to use the Oracle Wallet, same thing, you need to edit the OJDBC.properties file and only specify that line, oraclenet.wallet, etc. You see, and reference to the TNS admin. And after that, you need to make sure that you have Oracle PKI.jar, OSDT_core.jar, OSDT_set.jar, etc. Those files are part of the OJDBC 11-production. Remember, I mentioned this set of pre-established dependencies. So if you get that, you will get all those jar files. And make sure those jar files are in your class path, in addition to OJDBC 11 and UCP 11 and ONS.jar. Now we will see a demo of the IntelliJ plugin for the Autonomous Database. Here's the demo of the IntelliJ plugin for the Autonomous Database. The blue icon symbolizes the plugin. So we are selecting our free tier instance. In this free tier instance, we will create an Autonomous Database, selecting the compartment, providing a display name for the database, a database name, same as the display, the workload, transaction processing, provide the password for the admin, the licenses, and then click on create. Autonomous Database instance has been created. However, we need to check, go back to the compartment, and we can see the provisioning is still on the way. We refresh after a moment, and then it's provisioned. Right. Now we're gonna download the client credential. Those are files you need in order to connect to an Autonomous Database. We need to specify where we want to download the wallet. We already specified. We need to provide a password, and then we click download. The wallet has been downloaded. Now we're gonna use the wallet. We're gonna use some files of the wallet in order to connect to the autonomous database. In order to do that, we go back to specify the database name. The TNS refers to the tnsnames.ora file, which has all the files you will need to connect. And here we will inspect the file and find out the services that the instance support. And we pick one of the services. We use the admin username for the demo purposes. In reality, in real life, you will use a user. You will define a user. So the connection has been successful. Now we will take a SQL, a query console, take a query console, issue a SQL statement just to double check that the connection is indeed working. And that should just work. So yes, that concludes the showing the plugin and how you can use it to provision and to check the connection. Thank you. Back from the demo, this is how to scale. Let's discuss how to scale Java database access using either reactive streams or virtual threads. So what is the problem? The problem is with synchronous programming using kernel threads. Kernel threads are OS threads, operating system threads. Operating system threads are very expensive to scale, to schedule, etc. So let's say you have 1,000 of those. So 1,000 thread will be competing, for the CPU, and you will be scheduling, and you will have. So it's very expensive to scale. Let's say you want to have 5,000 connections to the database. You have 5,000 OS threads that will be competing for the cores of your CPU. So that's a difficult problem. So how did the Java community address this problem? Until recently, the Java community has been using what is called reactive programming. It's asynchronous non-blocking calls. So asynchronous calls has been around for a while, but what is new is the reactive stream. And reactive streams is a fancy name for asynchronous non-blocking calls with back pressure support. So you need a mechanism to control back pressure so that you don't send more than the client can sustain. Okay, so reactive streams has been being used by the Java community for a while, even though those were not part of the Java standard. But recently, starting JDK 11.9, Java has released Java Util Concurrent Flow, two APIs, the subscriber and publisher. So if you implement subscriber and publisher, you should be able to perform reactive streams with standard Java. Otherwise, you can use third-party libraries such as Reactor, RX Java, Akka Streams, Vertex, etc. So there are many libraries that support that. Lately, there has also been the R2DBC SPI that database vendors must implement. And we have released the Oracle R2DBC driver. So that's one approach the community has been following. Now, recently, the Java SE, which defines the Java standard, has proposed Project Loom. And Project Loom has virtual threads. The proposition of virtual threads is those threads are part of the JVM, are created in the JVM. The JVM is the virtual thread factory. So you can have thousands or millions of virtual threads in the JVM. They are scheduled by the JVM. So they are not competing at the same time for the OS, the kernel thread. At the end of the day, you will need a kernel thread to execute the virtual thread, but you can burn thousands of virtual threads without impacting the scalability of the system. So we will discuss all those things very quickly. R2DBC, I'm here comparing JDBC and R2DBC. So on the left, this is my left, this is JDBC. On the right is R2DBC. And you can see that in this first slide, we are just configuring the application to use either of drivers. So if you're using JDBC, you need to specify, you need to get a data source and then specify the host, port, service name, etc. If you're using R2DBC, where you need to get a connection factory and get a builder, and then specify, the driver, host, port, service name, etc., and then build the connection. Here is a query. If you're doing a query, you can see here that we have on the left on JDBC, we need to get a statement object, create a statement, specify the query, the SQL statement to be executed. Here we are just select from dual, and then execute the statement and get the result set, iterate through the result set. On the R2DBC side, we need to get we need to create a connection from the statement, and we're gonna return a flux. A flux is a streams type, a stream data types, which can have multiple elements. So here we have create a statement, and then we execute the statement, and we use a flat map. A flat map is an R2DBC, and you can see that as well in Reactor, and similar thing in some other third-party libraries where you apply a function. And here we are applying the map. We're doing a map. We are mapping. We are executing a lambda function to each row of the result set. So this function will just retrieve the first column, which is a string. In R2DBC, the first column starts with 0, whereas in JDBC, it starts with 1. So you can see that. And at the bottom of the slide, we are explaining what flat map are. And how to turn your synchronous database access to reactive. We are looking at the insert statement here. On the left side, JDBC, we get the prepare statement, and we are doing the insert into the table. Okay, and we are giving the values to the integer and the char file, the first column and the second column. And the JDBC first column start with 1, second column is 2. And so we are setting the values for the bind variables and executing the prepare statement. On the R2DBC side, we are returning a flux. So we create a statement. This is the insert statement. We are binding the value. So the first column is start with 0. We give it a value, it's an integer. The second column is a string. It starts with 1. We give it the value. We execute, and we return a flat map. We are executing the flat map to get rows updated, because when you do an insert, you return a count. So that gives you an idea. Now, what we have done to ease all those things is to provide a hook in the driver. We have what we are calling reactive extensions in the JDBC driver. You get the JDBC driver 11G, you get the reactive extension as part of the JDBC jar. So what we've done is we have implemented the publisher and the subscriber APIs for the Java util concurrent flow, and we're giving you those APIs, which are similar to JDBC APIs, but with async oracle at the end. For example, execute async oracle is similar to JDBC execute, but it executes asynchronously, and you don't have to code all the reactive stream API. This API, the reactive extension APIs, take care of that for you, right? So that's built into the Oracle JDBC. Now, virtual thread. As I said, virtual thread is a mechanism by which multiple threads, 100,000, are generated, are created, and scheduled by the JVM, and only compete for the thread when you need to get a thread. You need to get the kernel thread. So here, what we're doing is we are sort of configuring a new virtual thread executor, right? So we are creating a factory of virtual thread which will execute on the kernel thread. At the end, when needed, it will execute on the kernel thread. So with that in place, we will take this Java code. This Java code can be executed using either kernel thread or virtual thread, depending on how we specify what we specify in use virtual thread, which is a Boolean. So depending on the value of this Boolean, we will execute using the new virtual thread executor that was defined in the previous slide, or we just execute directly on the kernel thread, right? So that's what it does. And this code is similar, to just JDBC code. So you can use this approach to use your synchronous Java code, and depending on what value you specify, it will execute using virtual thread or using kernel thread. And here's a summary of everything the Oracle JDBC allows you to do. You can use synchronous blocking calls from the bottom here using either kernel thread or virtual thread, or you can use asynchronous call with non-blocking back pressure, and which is the extension. Or if you want full reactive streams with high-level operators such as map, reduce, and company, you can use either the R2DBC driver, or you can use third-party libraries, Reactor, RxJava, Akastream, etc., etc. How do you speed up the database access? GraalVM. I'm not gonna elaborate on what GraalVM is. I think people are familiar with that. So how do you do? Well, how does it work? This is a comparison with Hotspot just in time and GraalVM or ahead of time compilation. So you can see here, you generate your Java class, and then you compile this Java class to produce a binary which will run without the JVM. So the benefit here is instant startup, low memory footprint, and it works with memory management. Okay, these are the steps. If you are using just Java code, you have GraalVM, you install it, and then you use your own code, or you grab a code from our GitHub repo, compile the Java code into Java class, and then build an executable from the Java bytecode, and then run it. You could also do the same using an IDE, but to be honest with you, I have not tried this approach. So here's a summary of developing Java application with Oracle Database. So on the left are everything Java, Java framework, Java application server, all those libraries. They need to access the Oracle Database. They need to go through our JDBC and the Java connection pool. Right on the left, on the right is the Oracle JDBC, which gives you polyglot persistence, all the data models with the same engine, etc., etc. And in text, this is what I was just saying, but in text, so you can read. So we support all the open source micro framework, all serverless function, all the Java SC programming model, the Java EE programming model on server. We have integration with database resident connection pool, which is a pool on the server side. I did not get the time to discuss this. Support synchronous programming using kernel thread or virtual thread, async call, etc., etc. Call to action. You might want to attend the hands-on lab, live lab, hands-on lab, React plus Java plus autonomous database equal native cloud application. Okay, I will be your host on that workshop. And then you want to watch the on-demand session, Oracle Database, Kubernetes operator, why should you care? And then visit our quick start guide to develop Java application with the Oracle Autonomous Database. You want to get a cloud free tier account with 30 days credit to do whatever you want. So thank you for attending this session. Bye.